Cornell University 2019 3-minute thesis finalist. Katherine Adler, Civil and Environmental Engineering, Making Waves to Competitively Produce Biofuel.
Did you hear the youth climate strike last week? Ithaca was part of a worldwide movement of teenagers making waves about combating climate change. With my research, I'm literally making waves to combat climate change by making algae biofuel more competitive in the energy market. Algae has a lot of advantages over conventional biofuel feedstocks like corn. For example, it takes up at least 10 times less area, it doesn't require good soil quality, and it provides nutritious co-products. However, algae production is limited. One of the main limitations is the carbon supply. Algae, shown as little Pac-Man in this cartoon, consume carbon dioxide, or CO2, from the water around them to perform photosynthesis and grow. They deplete the CO2 from the water faster than it can be replenished by the air, so algae producers using raceway tracks like these have to get CO2 emissions from a fossil fuel power plant in order to feed their algae. Not only does this cost more money, significant amount, it also limits potential site locations of algae production by an order of magnitude. It also wastes a lot of CO2 into the atmosphere. What if instead we could get enough CO2 right out of the air? If we could get CO2 out of the air and into the water fast enough, algae production site locations would be way less restricted, and we could have a cheaper carbon-neutral energy source. So how do we do that? The Pacific Northwest National Lab used a chemical to double the CO2 uptake in an algae pond. But another twofold improvement would be needed before algae production can be completely independent from an external carbon source. Therefore, our goal is to also double the gas transfer rate, but by using hydrodynamics instead of chemicals. We know that little waves increase air-water gas transfer by stretching the water surface. So over in Hollister Hall, we lower cylindrical dowels into flowing water to make waves like the ones you get off the front of a boat. Our preliminary results show that these waves improve gas transfer rate by 25%, and there's a lot of room for improvement. We can still adjust dowel size, spacing, and shape in order to reach that 100% improvement goal. This may seem like a small incremental change, but if we superimpose enough of these little improvements, we can have a big impact on the energy portfolio of the world. Thank you.